In the last episode of TechTalk, we deep dived into generative AI, a topic that has become very hot since OpenAI released ChatGPT in December 2022. So, if you missed it, give it a listen. You probably understand how it works as a user, but are you familiar with the technologies that underpin the AI chatbot? These technologies are called large language models, or LLMs, and can generate human-like text on a seemingly limitless number of matters in almost any language, including coding languages. Impressive, huh? To explain what these models are, how they are developed, and how they work, that is, to the extent that we grasp how they work, we welcome Krishna Vadakattu, responsible for the artificial intelligence and machine learning roadmap at Dataiku. Krishna will also delve a bit into the use cases for LLMs and how to use them in an enterprise context. So, without further delay, let's jump right into it.
Welcome to a new episode of Tech Talk. This is episode 2, season 8, the one on data and AI season, and this episode is called the one on large language models. And I'm happy to have Armin here as my co-host as usual. Hello Armin, how are you?
Hi Caroline, I'm doing great. The summer is in full swing. The allergies are actively trying to kill me, but I'm not yet ready to give up.
I think it's getting worse, the allergies. I mean, I personally luckily don't have them, but I see in my team so many people suffering from those. It's a tough period.
Yeah, unfortunately, the global warming is just getting worse and worse every year.
Yeah,
currently.
but that's not why we are here today.
No, in fact, we have a much more interesting topic at hand, and one that everybody's been talking about.
Yes.
So today's topic is large language models, and
Exactly.
we found a perfect guest.
Yes.
So we would like to introduce to you Krishna Vadakattu. I hope I'm spelling that right, Krishna.
Absolutely.
Krishna is responsible for artificial intelligence and machine learning roadmap at Dataiku.
That's right. So Armin, do you want to ask the first question?
Yes, I think our listeners would love to know what is a large language model, the technology behind ChatGPT in simple terms.
So large language models are a type of algorithm. So within the field of artificial intelligence, the broad space that's been very exciting for the last 1 or 2 decades is this field around machine learning. And machine learning is really all about teaching computers to think or perceive, make decisions much like people. Within this broad field of machine learning, where typically you're giving examples of information, of data, and the expected outcome, there's a very popular field within that at the moment, known as deep learning or neural networks. And large language models, such as ChatGPT, are part of this family of algorithms that are based on neural networks. And what they're trying to do is understand the way language works and be able to automatically produce language sometimes that is much like how a person would react to, for example, an instruction.
Yeah, I did some reading before to prepare for this topic because I didn't know anything about large language models, and it sounds very complex. And you mentioned a neural network. What is it, and how does the brain metaphor language impact people's perception and awareness of LLM?
It's an excellent question, really. Where did this name come from, and what is the metaphor really about? So, in the brain, we have these connections that are known as neurons, and the neurons are basically the way that we process information or process sensory data in the human body. So when you see something, when you feel something, when you smell something, all of this signals are passed towards the brain and processed by neurons. And there's billions of neurons in the mind. And what they do is choose how you perceive and react to that external stimulus. And what we have in these neural networks that we're developing today, we have input information, data that's typically transformed into some numerical representation. And what you have are a network of smaller algorithms known as neurons. And these neurons can be as simple as a linear regression. So really the best fit line on a normal 2D chart. When it's a straight line, it's really just a linear regression. And what that's trying to do is fit some kind of approximate relationship between the input variables, typically what you'd plot on the x-axis, to a response, typically what you would plot on the y or the vertical axis. And neural networks are basically a collection of these smaller functions, smaller lines, you can say, that approximate to much more complicated relationships than you have on a 2D chart. More complex in both, for example, the number of dimensions, but also in terms of the sophistication of the relationship. So in language, you're describing something which is very context dependent. So the network is making relationships between the current word and words that were spoken earlier, because it's the sequence of words that really contains meaning.
That's super interesting. And how accurate is it, according to you? I mean, the metaphor, and what could be novel metaphors that could more effectively frame what LLM means for people's lives in general, and for the enterprise context in particular?
I think while neurons really usefully describe the sensation and the processing as it relates to machines, I think with large language models as a whole, and the way that it will, or that we're currently seeing it impact people's lives and the enterprise as well, is to think of it much more as a resource than an end product or a specific kind of subcomponent. I think emerging trends at the moment are to describe it as a construction material or a resource that you consume, much like crude oil. Crude oil has a variety of uses depending on the way that it's refined and adjusted. You have bitumen, the really kind of heavy long chains that are used for roads, all the way to kerosene for flying, and petrol and diesel for our cars, as well as plastics for everything in modern life. And these large language models are in some sense as versatile as oil. There are very primitive uses for them, as well as very sophisticated uses that can be made or applied to our everyday life, depending on how much refinement people choose to apply to these LLMs.
That's very interesting. Could you better describe what is a neural network architecture and more specifically the transformer?
Sure. So if you imagine a single line of best fit on a chart, that is clearly super helpful to describe many relationships that are linear or proportional in some sense. But quickly you can understand that there are some relationships that aren't linear. Some follow a curve or some other trajectory. And this is just when we're sticking to 2 dimensions. The way that you can choose to approximate some of these more complex relationships is by choosing a function, something that's no longer linear, but something potentially quadratic or otherwise. But you can also choose to connect functions together. And in some way, that's what this neural network or the network part or this architecture part is really about. It's really saying that when you have some input information, rather than making a decision based on passing that through 1 neuron or 10 neurons, why don't you pass it through several layers of neurons to capture more complex relationships? But when you have these several layers of neurons, there's actually lots of interesting things that you can do in the way that you make connections between the neurons. And those different connections between the neurons are capable of capturing nuances in the input that otherwise would have been missed in a simpler structure. And that's where this architecture element comes about. It's the arrangement, the connections between these different aspects of the network. The transformer is a specific type of architecture that's proven to be very effective at capturing the sense of natural language. Originally, it's something which came out of research done at Google working on translation. There are different types of architectures for different use cases, and this particular architecture has some characteristics that turned out to really surpass earlier approaches for handling natural language. One of the key points was introducing the notion of a sequence in a novel way. They called it positional encodings, but in simple terms, what they did was not only pass in the words to the model, but also the numerical order of the words to add extra emphasis on the relative position of words and having that context in the sequence. And earlier methods didn't explore this in the same way, and they really relied on earlier words or tokens in this neural network and large language model context, as they're known. They really were dependent on earlier bits of the sentence still being connected to the current word in the sentence that you were trying to analyze. So transformers really came across a new paradigm where they were able to more intelligently remember and attend to earlier words in a sequence. And this notion of attention is a way of really being able to focus on specific things that were said that can depend on context. So it's not just about the model focusing on the most recent words in the sequence, but it's also able to selectively focus on words that are relevant earlier on. So when you are passing in a lot of information, a lot of text, and asking it to learn patterns, it's able to understand that the same word in a different position in a sentence or the same word in a different context can convey different meanings. And that was one of the big improvements with the transformer architecture versus earlier architectures that were common for natural language prior to that.
Great. And how do you define the architecture for the model?
This is actually something that's a bit of an art. At the moment, this is what a lot of research goes into. And it's one of the things which has been very democratizing of the space in the last 10, 15 years, where as more and more researchers and enterprises have had access to the necessary technology to explore, people have tried different architectures, basically different layouts and connections, different functions in the neural network or this field of deep learning. And empirically, they have discovered certain patterns which seem to come up with better performance under certain use cases.
All right. And to what extent do they change according to the use case?
That's really crucial, in fact. So what we've been talking about at the moment in terms of natural language is very sequential. It's very important to have some memory of what's been said and the context of that. So there were a lot of approaches before that have been very focus around this idea of sequences. And this is also relevant in time series, where you're trying to, for example, forecast the next event that's going to happen. It's very dependent, usually, on what's happened earlier. If you contrast that to image recognition, an image, if we put aside video, is a snapshot in time. So there's less emphasis on this idea of sequencing at all, but actually the spatial position within an image is actually much more important, and it's very relevant. And the predominant neural network architecture for image recognition, the last decade, has been around this family known as convolutional neural networks. And rather than emphasizing the focus to connections earlier in a sequence, it actually emphasizes the focus of connections around a specific part of a photograph or a specific part of an image. So a photograph is made of many pixels, basically, the different colors arranged to make an image. And the convolutional neural networks, they add weight and emphasis to the pixels around a specific pixel. So you have this spatial representation that's captured.
Programmers define the architecture for the model, but not the neurons themselves. And this happens during a phase called training.
You did some research as well.
Yeah. Could you describe the process and some of the related terms such as pre-training, fine-tuning, and domain adaptation?
Absolutely. So while you as a developer, as a data scientist, may have the structure in mind that you think is going to capture information, you, much like, I guess, when you see a relationship that on a 2D chart that you think is roughly straight or proportional, you don't know exactly until you do a calculation what's the best line to fit. And the way that you fit that line traditionally is you calculate the minimal error, let's say. So what line is closest to the most points is how you do it in school. With neural networks, it's relatively simple, or relatively similar at least, for the program to go through and calculate the error when you pass it some training information. Training data are the input examples that you have a labeled outcome that you would like to achieve. And what you do with this training phase is that you pass in lots of records and you measure the error that the model delivers. And there's a process known as backpropagation, where you're basically trying to pass back through the network the error in such a way that the model adjusts to produce less error the next time. And through this iterative sequence of adjustments, the model learns or trains to do this predictive exercise with the smallest amount of error. And that's how the let's say the weights, the specific, I guess, numerical representations of the neurons are adjusted, even though you just gave them an architecture at the beginning.
Great, that was very clear. Which are the most relevant applications of LLM in the enterprise context? So let's get practical.
Can you name some relevant use cases for us as well?
Absolutely. So a lot of what you're seeing now in large language models, you've got an opportunity to do things which are relatively formulaic. So let's imagine you've got operations in many organizations. You have several examples of how something should be processed. Imagine you're an insurer and you are trying to service the claim submitted by your customers. Something that's quite straightforward is triaging the claim. So that would be someone taking a look at a ticket, an email, and understanding, is this a claim for travel insurance, for medical insurance, for damage to a property? So this is classification or triaging. But then as you go beyond that, you have to read the claim, to understand the claim, to maybe identify the key aspects of the damage or the incident and the circumstances around the incident. And right now today, you have knowledge workers that will go through and read a document, will read perhaps the tickets, the receipts, the invoices that are related to an incident, and populate some data sets. And that's something which these LLMs have really been able to get into. On the flip side, there's a lot of interest in the experience that ChatGPT has shown to everyone all around the world. That, well, what if the robots and the chatbots that you've seen on the phone and also on mobile apps and browser experiences, what if the interface to get support from my service provider is smoother, or it's more intelligent? A lot of times you feel in an early part of the conversation that it's very prescriptive. It's very likely that the robot or the chatbot misunderstands you. But what we're having with ChatGPT is this experience which feels much more intelligent because it understands more about the context of what you're doing, as well as earlier messages in a way that existing robots and chatbots haven't been able to capture. So there's something in this question and answer space that, again, seems to be proving very popular amongst our customer base.
Could you mention who are the key ecosystem players and what considerations enterprises need to take into account when developing LLM applications?
Sure. So at the moment, the market is spread out into several tiers. You have infrastructure providers such as the clouds, that are both trying to offer the infrastructure for you to build and to train these algorithms, as well as serving their own algorithms for you to consume. Then you have, for lack of a better term, model providers. So you have participants like OpenAI, Cohere, Anthropic, which are offering AI as a service. So you can consume and use their model that they've made directly, and you don't have to worry about running the infrastructure or training it necessarily. And then you also have open source model available on marketplaces such as Hugging Face. So Hugging Face is a little bit like GitHub for machine learning. People train models and share the models publicly. Of course, there are licenses that they can choose from when they share. And you can download and adapt or run them as is. And these are the, let's say, the more kind of lower and mid-level applications. And then, of course, you have tons of companies coming up right now which are offering verticalized solutions. So people that are trying to take care of both the infrastructure, the model, as well as the business layer. So for a specific industry, for a specific function in the organization, they would like to crack that problem or really revolutionize some process using large language models just there. So in this claims example, you have this space of providers that would really like to offer a kind of claims management solution for a specific type of insurance, let's say.
So many business opportunities coming out of
Absolutely. And there's a lot of considerations to take into account when you are trying to work on these applications. One of the big things that is coming up in conversations a lot at the moment is data privacy or data sensitivity. There are times when you're working on data or you're working on use cases which are relatively public facing. So you're not really concerned about training the model in a way that's very private and secure because the information that you're using is publicly available. So imagine training information on your public help or FAQ site. That's probably not too sensitive. But there are other examples where you might be training on very personal and sensitive information, whether it's financial or relates to people's personal being, health. Then quickly the mindset shifts from using a model, an AI as a service provider, to what can I do with open source models and train and adapt them in my own environment. And then, really, regardless of which of these angles that you go through, one of the things which is a key component of using transformers and these large language models is that they've been pre-trained. A question that you mentioned earlier. The notion of pre-training is really that someone elsewhere has taken typically a very large amount of data. We're talking in the order of Wikipedia and larger, hundreds of gigabytes, and they've used that information to train the model. But unfortunately, when you scrape that much information, even from a mixture of reliable and relatively speaking trusted sources, it's very prone to catching human bias in unsavory ways. And that's something that you need to take into account when you're developing these applications, which is what is the risk of generating outputs which are not in keeping with the principles and values of the organization. The risks with these models are slightly different than with traditional machine learning models.
Okay. Can you tell us more about your organization? How does Dataiku support enterprises and quickly integrate LLMs into their operations?
Dataiku is really a platform for innovating with your data. And one of the key things that we support is all things around data science, both for the expert, the data professionals, the data engineers, scientists, as well as the more domain experts and the business personas. So what we try to do is offer a suite of functionality for both halves of the house. So for situations when you're just trying to employ large language models to do something that's quite prescriptive, we wrap all of this complexity up into a very simple user interface where you can develop your prompt flows or your use a very simple point and click solution to go from your claims, as our early example was, to simply the categories that you're interested in classifying them into. Whereas for the data scientists and data engineers that are working on the models themselves and really getting into adapting those models to the specific organization, what is known as fine-tuning, we basically offer experiment tracking as well as deployment for that in a much simpler fashion than we'd have to go about it if you were doing it entirely through code. So we have integrations with popular frameworks that help you log all the information with easy comparison, and then also be able to quickly turn that into an API or a batch job that's able to then run that fine-tuned and that customized model over and over again.
What is unique about it?
The one thing which is really special about our platform is the opportunity to bring these different profiles together. Typically, you have silos where the data scientists or data engineers are not as close to the business, but are really experienced and working most heavily on the implementation. And on the flip side, the people closest to the business, closest perhaps to the end customer, may have really valuable domain expertise to input and share in the application that you're tackling, but find it difficult to contribute. And that's really where having this one platform where everyone can play in this as a team sport together is really differentiating. So you now have opportunities for those domain experts to embed their business knowledge into the pipelines and into the model experience that the data professionals, the scientists and engineers are working on. So that it's really something that's making LLMs more accessible and kind of democratizing their power to more people in a way that would be very bottlenecked around the few data scientists in the organization that are familiar with large language models and natural language processing technology.
Fantastic. Krishna, now I will ask you to take out your crystal ball. And I will ask you which are the future applications that you envision for LLMs. So according to your knowledge and expertise, how do you foresee it evolving in the coming weeks, months?
It's a very exciting and fast-moving pace. So I can only imagine making predictions for the medium term, on the short term, really. On one hand, there's a huge demand for these models to become smaller. Smaller in the sense that more people are able to train, adjust, adapt, customize them, and also execute them on smaller devices. Smaller devices meaning laptops closer to consumer grade and the phones that we have around today. And this is going to really revolutionize the experience you have when it's much more personal and tailored to you. Imagine the opportunity that something has learnt the way that you like to communicate and learnt the way that you like to be communicated to in the experiences in your day-to-day life. On the other hand, there's a lot of work going on about mixing different modalities. By modalities, it can be audio, text, imagery. And we're having releases regularly in the traditional creative spaces being really augmented and accelerated by having people describe the outcome that they're looking for and having the program, the software in between, jump you to there, really giving you a head start. So there's examples with Photoshop, there's examples with creating videos and storyboards where you're more or less describing the outline of a presentation that you are looking to build or an analysis that you like that's going to be prepared for you. And going beyond that, people are chaining these models together to accomplish more complex tasks. So, imagine you're looking to plan a holiday. Planning a holiday is pretty complicated. You have a lot of constraints that are evolving as you go through the search. You need to narrow down a place. You need to narrow down how you get there, where you stay. Even when you've made these broad decisions, the specifics of which route you take and what kind of room and specifically the circumstances of your trip and what you go see takes a lot of research.
Yeah, I think we can all relate to that.
But now people are working on models that actually approximate the work that you do or a travel agent does by interacting with each other. So you go describe loosely the experience that you're looking to have. I'd like to relax somewhere warm in June. And it's actually breaking down the intent behind what you're saying. So when you say warm and when you say June, it's able to, for example, talk to different weather services, talk to different mapping services, and narrow down a set of places. And then further filter the activities or the predominant choices available in those locations to be geared to what you might consider relaxing. and then further refine that to prices and times. And now it's a very tailored experience where maybe you could just converse as you would, for example, with a travel agent on deciding what your experience is going to be like. So you have these different directions where models are becoming more powerful just in terms of understanding language better, or creating more attractive art. You have models that are getting smaller and more accessible to more people and experiences, so they're going to get more personalized and tailored. And you also have this complexity of like basically multiplying models together and getting them to do increasingly complex things. You'd never train such a model to take holiday preferences and produce holiday itineraries, but you could connect a series of models together that do something like that. And that's really the emerging patterns that I predict for the coming year or two ahead. It's more impressive applications of connecting things that would be tedious for people to go about and do today.
Great. Well, it's a very exciting field. I guess also a little bit scary to hear these things because, well, I'm human and everything that is different scares me a bit, but I look forward to seeing how this develops.
Yeah, exciting times ahead for us. Thank you so much for joining us today and spending your valuable time with us.
Yes, Krishna, it was a pleasure having you.
Thanks for having me on the podcast.
Thank you. Bye-bye. And that's all for today. This is TechTalk, technology made simple over a cup of coffee. Don't miss out on any future episodes by hitting subscribe. Thank you for listening, and until the next episode.